Welcome STAT students to week 11 of maintenance. Here we are doing a survey of meat and certain types of takeaway meals, and we want to calculate an estimate of the mean and standard deviation. So the first step is we want to find the mid-interval values. So 3, 8, and then 31 divided by 2. So 15.5. 15.5. Next one be 5.5. And the last one is 40.5. Now to get the mean is going to be, we're going to divide by 193 since that's how many meals we've got. And we're going to go 59 times 3 plus 67 times 8 plus 38 times 15.5 plus 18 times 25.5 plus 11 times 40.5. Now what does this actually give us? So 59 times 3 plus 67 times 8 plus 38 times 15.5 plus 18 times 25.5 plus 11 times 40.5. This is giving me 11.43. That's my estimate. I'm going to save my unrounded version in my calculator. Now the standard deviation is going to equal the square root of the sum of x squared f over n minus the mean squared. Now we could probably want to chuck in our x squared f, so it's like, I'll add an extra column. I know this is a bit messy. Where can I do it? I'll add it straight under here. So it's like 3 squared times 59. So 9 times 59, which is 531. This is x squared f. Next one is 64 times 67. And that's 4288. The next one is 15.5 squared times 38, and that's 9129.5. Next one is 25.5 squared times 18. And this time we get 11,704.5. And then the last one, 40.5 squared times 11, and that gives us 18,042.75. 18,042.75. And then we're going to add all of that together and divide by 193. So let's see, what do we get when we add that all together? 11704.5 plus 9129.5 plus 4288 plus 531. That's a big number. So we got 43,694.75. All over this should be 193. Takeaway. Now the mean, which was at 11.4 squared. Okay. So what do we get? Minus a squared answer. I'm getting 9.78 for that one. And so for the probability question, we've got some data on GDP and birth rate in 170 countries. This chap's classifying GDP as either and birth rate as low, medium, high, as we see in the two-way table. And we've got to find the probability the country chosen, random country chosen, has a medium GDP. So that is all the way along here. So out of 170, what was that? 74, I think. Over that, so that's 37 over 85, I think. Now, find the probability that the country chosen has a low birth rate, given it doesn't have medium GDP. So, probability of a low birth rate given not medium GDP. Okay, well, that is equal to the probability of low birth rate intersecting with not medium GDP, all over the probability of not medium GDP. Now, the denominator, of course, is going to be 1 take away that, because that's what a medium GDP is. So if we subtract that, or 170 minus 74, so we could get, it's 96, or 48 over 85. And the probability that we get a low birth rate and not medium GDP is this bit and this bit, you can see. So that's 38 out of 170. So now when we just put that all on our calculator, we get 19 over 48. So 19 over 48 it is. The next one is about mutually exclusive. State with a reason whether or not the events, the country has a high GDP and the country chosen has a high birth rate, are exclusive. Now, if they're exclusive, that means that there's no intersection between these two things. So if you think of a Venn diagram, and if this one here is high GDP, and this one here is high birth rate, there's nothing in here, but there's nothing that's both high GDP and high birth rate. And if we look at our table here, we see that there is nothing that fits the category of both high birth rate and high GDP. So I would say yes, they are exclusive. And I might say because there are no countries that have both a high GDP and high birth rate. Okay, now moving on. One country is chosen at random from these countries, which will have a medium GDP, and then a different one is chosen from those. Oh, hang on, wait a second, read carefully. One country is chosen at random from those countries which have a medium GDP, and then another country is chosen at random from those that have a medium birth rate. Find the probability that both countries have a medium GDP and a medium birth rate. Okay, so let's go back to our two-way table here. What is the chance that we pick something? We've got to pick the first country from a group that have medium GDP. So we go to our medium GDPs, and here are our medium GDPs. And then After that, we're going to pick one at random from those that have a median birth rate. So we're going to go downwards here. And we want to know the chance. Maybe I'll copy this down so I don't keep on having to scroll back and forth. So we want to know the probability that both countries chosen have a median GDP and a median birth rate. Okay, so obviously we're thinking about that middle section there. So when I choose my first one, you can see that there's altogether, is it 74? And 42 chances out of 74 that we'll pick one that's also got a median birth rate. Then with the next one, you'll notice that we now actually just have 73 options left because we've picked a country already, and there'll also be only 41 in this category because we've chosen one of those. And oh, hang on, I'm picking from a different row, so it might not be 73. Now I've got to count up this way. So yeah, 41, 49, 50, I think it's 54. But out of those, should have 41 options. So let's just do that. 42 over 74 multiplied by 41 over 54. That gives me 287 over 666. Okay, there we go. Okay, we come now to discrete random variables question. We've done a little bit of this in class. Well, we've got this probability distribution. We've got x can take on four different numbers, -3, 0, 2, or 4, with the probability for x being one of those values, p for -3, q for 0, r for 2, and 0.4 for 4. And we are given that ex, the expected value, is 2.3, varx is 3.01, and we've got to find p, q, and r. This is a simultaneous equation sort of scenario. So for ex, remember ex is equal to each of the values of x multiplied by its probability. So -3p plus 0q, which of course is just going to be 0, plus 2r plus 4 times 0.4, which is 1.6, equals 2.3. And we can simplify this to -3p plus 2r equals 0.7. Now with varx is this. Varx is equal to ex squared minus ex and squared. So in other words, we can write -3 squared p plus 0 squared q plus 2 squared r plus 4 squared times 0.4 minus the expected value squared, which is 2.3 squared, equals 3.01. Now let's just get this all together. So we get 9p plus 4r, 16 times 0.4 minus 2.3 squared, and then we bring that over to the other side. We get 1.9. And then the final thing that we can say actually is that p plus q plus r plus 0.4 should be equal to 1, all probability adding up to 1. Now I'm going to work with blue and red to start off with. I'm going to times this blue one by 2, so I get -6p plus 4r equals 1.4. And now I'm going to use a simultaneous equation. So I'm going to add this 1 and 2, and I'm going to subtract 1 from 2. So I get 9 take away -6, which is 15p. And then I get 1.9 take away 1.4, which is 0.5. And so p is equal to, what's that? 0.03 recurring, or 1/30th. Now, therefore, we can say r equals, and we substitute that in. So 9 over 30, 1.9 minus 9 over 30, which is 1.6, and we divide that by 4 to get r, and that's 2/5 or 0.4. And now we can finally work out what q is, because everything has to add up to 1. So just using the green formula there, if I go 1 minus 0.4 minus 0.4, which I've just found out what r was, minus 1 over 30, and I'm getting 1/6 for q. So I think that's actually it. Should be done. Hope that makes sense. Let me know if you have any questions or queries. Alright, see you later, team.